All right, you ready? This is just a little help here. Probability with permutations and combinations, all right? In general, you want to ask yourself, determine, does order matter or not in this scenario? And I think by now you probably know what I'm talking about. Are we making teams? Are we lining up for a picture? Okay. Does order matter here? So if yes, we use perms. If no, we use combinations. Determine if the total possible arrangements given no restrictions. So this right here is your NU. I'm going to put that, I'm going to highlight that. All total possible, this is the sample space or the universal set, that is your NU. Because remember what probability asks for is what? The total, right? Denominator is always the total. So that's where we're going to focus on NU if you're asked for probability. Third, determine the total desired or favorable outcomes. I'm going to give this a different color so that there's a contrast. Based on the conditions or restrictions given. This is NA. Okay, that's NA. That's like the events we're after, and NU is all possible events. Write the final answer as a fraction. It's in general is like this, and I would make sure I have that little note, largest number. You know where students mess this one up the most is when I ask you, what's the probability of it not happening? They start something fancy at the top, and then the bottom is like a weird small number. And just make sure whatever you do, that has to be the largest number between the two. Okay? All right. So remember, just a note here. You can convert probabilities to odds. Remember that. So even if the question asks you for odds, sometimes I may choose to first come up with the probability, and then I will turn it into odds. Okay? All right, let's do our first example here. There are 4 band and 6 dance students. A teacher would like to select a team of 4. What is this going to be? Combinations, right? It's teams. Teams of 4 to represent Sisler or a convention. Now I want you to read carefully. Ask yourself, what's the probability? It's asking for a probability. You better come up with a fraction of some sort or a percentage of having a team with exactly 3 dance students. Exactly 3 dance students. So how would we do this? Probability is NA over NU. And I'm going back to chapter 3 on this, right, with my notation. Right? These are teams with 3 dance students, and NU is all possible teams. Right? There's students with 1 dance student, no dance student, right? All dance students. Everything is in the denominator. So let's do NU first. How would we come up with all possible teams? What would we use in terms of notation? We don't care dance or band, right? We don't care. So we've got 10 in total, and we're just going to choose 4. That's it. So we've got 210 teams. That's it. That's your universal. NA. Now we're picky, right? Now we want to distinguish. So let's make sure that restriction is met. Exactly 3 dance students. So we got to go find out how many dance students are there. 6. And we're going to choose exactly 3. And that's okay, Mr. Dirksen, right? We're good? Because no, you're making teams of 4. Right now you have a team of 3 if you just left it like that. So we got to go 4, choose how many more? Just 1 more. There we go. 6 choose 3 is 20. 4 choose 1. That one you should remember. Anything choose 1 is just the first number here. So that's 4. So that's 80. And now you have your probability. So probability of 3 dance. This is 210, and this is 80. You can cancel out the trailing zeros at least. I think that would be pretty doable. That would be my answer, but sometimes the province says state it as a decimal. So moving forward, if it's decimal, I'm just going to state it to 4 decimals, okay? 0.3810, because the 9 bumps to a 10, which bumps this to a 1. So that's 10, which means that's 38.10%. So then you can just shift the decimal and you'll get it right every time. You don't have to worry about rounding 4 decimals. Except if it's not money, you can do as many decimals as you want. Okay? Okay. Let's do the next one. What is the probability of having at least 1 band student? First of all, emphasis on probability. Then the emphasis on what is the restriction? At least 1 band student. We already know NU, right? We know NU, we've already determined that in A. We know it's 210. So that's taken care of. Let's do the NA here. How would you meet this restriction here? At least 1 band student. At least 1. So we're going to go total minus, what are we going to subtract? No band students, right? Let's take away the teams that would have no band students in them, and then, Mr. Dirksen, we're left with everything else that have at least 1 or more. Okay? So total is 10 choose 4 minus no band students. So I gotta split them up. From the 4 band students, I'm going to choose none. And from the 6 dance students, I'm going to choose all 4. And I think this goes without saying. When I say no band students, you're really saying all dance students, right? All teams that they're only made up of dance students. That's really what this is saying at the same time. So we know that this is 210. 4 choose 0 is just 1. 6 choose 4 is 15. So that's basically 210 minus 15. That is 195. So and that makes sense, right? We want this to be smaller than 210. So here's my probability. It would be 195 over 210. I'll just leave it like that. NA, NU, NA, NU. That's how probability works. Okay? So you're kind of going back to chapter 4 for a little bit. You're doing your work, and we're basically just learning how to stack them. Okay? That's basically what we're learning to do. We're stacking them because we're turning it into a probability. What are the odds of having at least 1 band student on the team? So Notice that it says odds, right? I was nice enough to put it in bold and to underline odds of at least one band student. Because it's of, we know it's going to be at least a band student versus no band students. How many teams have at least one band student in it? We already know that. 195, right? So you put 195 here. And how many do not have any? Depends on how you want to do it. If you want to go off of the probability, I would just go 210 minus 195. So it's 195 to 15. But let's imagine this is a multiple choice question and this does not show up. Do you remember how to reduce it? They're both divisible by 5. But I take the smallest, divide it by the largest. I kind of make a fraction out of it, and then I go math 1 equals. So it's really 13 to 1. Okay? That's my trick here to reduce odds. 13 to 1. These are the odds of having at least one band student. So this is a combination example. Let's go to page 16 and do a permutation example. And remember, if you're doing perms, you can always do a fundamental counting principle as well. John, Ethan, and Adriana are competing with 10 other runners in a cross-country competition. So these 3 and 10 others, so 13 total, right? If all runners have an equal chance of winning, determine the probability that of John, Ethan, and Adriana to win the first, second, and third place. Okay, if you have first, second, and third place, order matters. Okay, if it says in any order, it just means that it could be John first, Ethan second, Adriana, right? Like they can go anywhere. So we can go NU. Let's do that first. Don't put an equal sign. Just say I'm solving for NU here. How many ways can first, second, and third place be awarded in general if these 3 characters aren't involved? How many could finish first? 13, and then 12, and then 11. Or 13, pick 3, right? Picking the first 3 spots. That would be 1,716 ways. NA. First, second, and third. How many are we considering now? We only have the 3 characters, right? So out of the 3, right, to come in first, there'll be 3 options, then 2 options, then just 1. We're just zooming in on just those 3. Or 3 pick 3. That is 6 ways. Now stack them. Probability is 6 out of 1716. Can you reduce that? Probably. You should use this function, if at all possible. 1 over 286. And if you wanted to state that as a decimal, because we don't want to forget how to do that, it's a really small number, right? 0,0035. And if you multiply that by 100, this would be 0.35% if you multiply that by 100. But I would say if you know how to stack it, when it's probability, stack it. Okay. I'm going to pause here and ask you to try some. And I'm going to say this. You need to, by the end of this week, have done all of these questions. Okay? Attempt it. Sure, got them wrong, but when you come back to class and I go over them, you should have tried it. Don't just copy it for the first time when you come in. Okay? So I'll give you the rest of today's class to get this started. Remember this, NU, you do the total first, like how many are possible. Forget the restrictions. And then you figure out, okay, now zoom in NA, which should be smaller than NU, right? And you'd be surprised how many marks you can still get if you show your work. Even if you get the initial part wrong, maybe you interpret it wrong, but if you do the rest correctly, you still earn marks there, okay? So let's see how this goes.